In order to use all 4 TS inputs, the multifunction pins must be configured appropriately on the EVM. The BQ40Z80 has 2 dedicated TS inputs, which may not be enough for applications with a high cell count, so the multifunction pins can be used for TS3 and TS4 as well. Make sure the jumper connections on the board as well as the register settings are configured properly. The pin configuration register in BQ Studio controls the behavior. The TS inputs can be configured to report as a FET temperature in DA status 2 by setting the corresponding flag in temperature mode and DA configuration. When configured this way, the TS input is not used in the gauging or advanced charge algorithm simulations. Since the BQ40Z80 can be used in a wide variety of applications, and the applications can have a wide variety of requirements for system-level function, one of the new additions to the BQ40Z80 is the ability to configure several pins, up to 8, as general-purpose input-output pins, or GPIO. The capabilities of the GPIO depend on the pin chosen, and the capabilities are detailed in the BQ40Z80 datasheet. There are 2 low-voltage GPIO pins on pins 12 and 13. There are 3 high-voltage GPIO pins on pins 15, 16, and 17. And there are 3 GPIO pins on 20, 21, and 22 that are normally configured as LED outputs so they can sink higher current than the other GPIO. The GPIO can be configured as input or output and can be configured as output low, output high, or high Z. The default configuration of all the MFPs is as high Z to enable a safe state for configuration during production. Using the GPIOs is straightforward. Use the GPIO read command to return an 8-bit field, with each bit providing the input level read from each of the 8 pins that can be configured as GPIOs. The command returns valid data for all pins configured as GPIO, including those configured to drive an output. Use the GPIO write command to set the output drive of each GPIO pin configured as a GPIO. The format of the command is a 16-bit field with 2 bits associated with each GPIO pin. This is shown on the map here. These 2 bits set the output drive status as 00, or drive output low, 01, drive output high, 10 or 11, set output high Z. The BQ40Z80 supports generating interrupts on pins configured as GPIOs. It includes a flag mapping function for these pins, which is a bank of 8 control registers, flag map setup 0 through 8, that enable up to 8 separate flags in the device to be mapped to 1 or more GPIO pins. Flags may be ORed or ANDed together to trigger an interrupt on a particular GPIO pin. For example, up to 8 different flags can be ORed onto a single GPIO pin, or up to 7 flags are ORed together and then ANDed with the 8th flag to trigger an interrupt. On this page is an example for using a GPIO as an interrupt based on 3 specific conditions. In this case, I'm using flag map setup 2 to trigger the active high interrupt on pin 12 only when the battery is inserted and either X charge is set or CF is set. Operation status present tells me when the presence pin is pulled low, indicating the battery is inserted into the system. Operation status X charge tells me when charging is disabled. If X charge is set to 1, then I know that charging is disabled. Operation status CF tells me the status of the condition flag. If CF is set to 1, then I know that max error is greater than the max error limit and a condition cycle is needed. The first step is to set the flag enable bit to 1 to enable the control. Next is to set flag reg bits to select which register contained the flag. There are registers available such as battery mode, battery status, operation status, charging status, temp status, gauging status, IT status, safety status, and PF status. In this case, operation status is set by selecting OX02. Next is to use the flag bit to select which bit in the register is used. In this case, OXOE is selected for the X charge bit. Since I don't want to change the polarity of the bit when monitoring it, I leave the flag pole bit set to 0. In order to map the interrupt to pin 12, I set flag GPIO to 0x7. Now for the logic. I have the flag OR set to 1 for the OR operation, and the flag OD set to 0 to select driven high, driven low. The other option is to set it to 1 and have it be driven high or high Z or driven low. I follow the same process for the CF bit. Finally, I configure the pres bit in a like manner. As you can see, this is a very powerful addition to the BQ40Z80 and provides a way to have interrupts generated without having to poll the device for status. For many applications that are on a dock or in a low power mode much of the time, this can have a large impact on the total runtime as well as the robustness of the system.